Good morning, grade 9 math. Mr. Andrews here, and a couple days late on the kind of lesson on dividing polynomials. So I'm going to quickly show a couple of examples with dividing polynomials, and hopefully you will take something away from it. And shortly after this, I'll do one for the introduction to circle geometry. So check it out. So what we need to understand with dividing polynomials is the premise, first of all, if we were to have, something like 3 to the power of 4 divided by 3 to the power of 3. So if you recall from our powers exponent square roots unit that there is a rule that says that if you have the same base, so the base is 3, we do what with our exponents? Well, we subtract them, okay? So this would simplify to 3 to the power of 1. So the same thing would happen if you had a letter. So if we had y to the power of 4 and y to the power of 3, same thing would happen there. So we would subtract our exponents. Our base stays the same, so that would simplify to y to the power of 1. So we need to know that because when we're looking at dividing something like, if we're looking at dividing something like this, negative 3x squared plus 9x minus 27xy, and we are dividing by 3x, and we're dividing every one of these terms will be divided by 3x. Okay, so I'm just going to move this up just a touch. So now we look at this as negative 3x squared divided by 3x. So what we're looking for here is the fact that this term has an exponent of 2, and this one has an exponent of 1, right? So this would just simply be negative 3 divided by 3 is negative 1. So the simplified answer for that would be negative 1. And then x squared divided by x becomes just x, because 2 minus 1 gives you that exponent of 1. Next, we'd move on to the next term, 9x divided by 3x. So 9 divided by 3 is 3, so this becomes plus 3. X divided by x, they both have an exponent of 1. 1 minus 1 is 0, so there is no more x there. And then lastly, we have negative 27 xy divided by positive 3x. So negative 27 divided by 3 is equal to negative 9. Oops, wrong color. Negative 9. And then x divided by x is 0, and then there's y divided by nothing, so that would leave the y behind. So that's a more challenging division question that you can work from. So let's move on to modeling these guys. So we're going to model a division question. So, if we had something like this, so if we had this might take me a few minutes to draw, but if we had these 3 tiles, and they were labeled as y's, and then we had this guy here, and this was a negative xy. And then we did that again. And then one more time. I'm getting a little sloppier as I go along. So these are all y's. And these are all negative xy's. And then this is what you see. So you see this on your page. So you can see with division modeling, basically you can see that this group of tiles is divided into 3 groups. So we have one group here, we have one group here, and we have one group here. So we know something is going to be divided by 3. So the something that's being divided by 3 is the entire group of tiles. So this entire thing is being divided by 3. So the way you would write this would be, so how many y's do we have? We have 3, 6, 9 y's. We have 9 y's. And then we have 3 negative xy's. So it'd be minus 3 xy. And that's being divided by 3 groups. So that's how you would write that particular model. I'm going to move my head up here. Whee! And then the answer would be one group. So the answer is, how many apples does each person get, or how many oranges does each person get? Well, this person would get 3 y's and a negative xy. So that's how you model division with polynomials. So hopefully this short and sweet lesson will help you along the way. I'll post this on Teams as well as on the class tag as well, and you'll see my circle geometry one coming up here shortly.